Okay, welcome to, I guess this is part three or whatever. So I'm going to show you how to do the UML. So we're going to start with UJImage because UJImage is the one with the most functions or implementations, right? So I'm going to open Dia and then I'm going to try to be as quick as possible since you guys are already familiar with UML. So I'm going to choose the class template and then drag and drop it here and then double click to make changes. So I'm going to give it a name and call it UJImage. And then attributes just means the variables, meaning anything that's under the protected or private area. That's where you put attributes. And then operations, it's methods and it's functions and constructors and operators, operator overloading, right? Remember, operator overloading is just functions. So let's start with attributes. Um, okay. So let's start with attributes. So I have UJ pixel. You could you could specify what UJ pixel is, but for the sake of simplicity, you won't have time, so I'm not gonna specify that. Like create a small diagram on the side that represents UJ, for example. Okay, this is templated. Um, okay, it's not there to represent a structure, so just leave it. So UJ pixel, so let me click new to add a new attribute. Its name, I've called it underscore pixel. Its type, it's UJ pixel. Pointer. So you need to put those pointers there. And then visibility, it's going to be private, right? Class scope, it means that it's static. You choose class scope if that variable is static, meaning that it's part of the class, it's not part of the instance. Hence, it's called class scope. Then render, which is composition, but for now we're just typing variables. We'll denote that we'll put those symbols later. So render a pointer, and this is also private, and then apply. And then I have rows and columns, underscore rows and columns. So underscore rows, and then the type is unsigned short, which is just we can say unsigned short or unsigned short int. It's up to you. I'm just going to choose to write it in full on the UML, but it's not mandatory. Remember, UML, you're just writing everything that's as it is here. And okay, you'll be using a computer, so you'll be using DS, so it's fine. You don't have to remember whether minus, that's when it's private, plus, that's when it's public, hash, that's when it's protected. You don't have to remember those keywords. You just choose when you're adding those variables. So underscore calls, unsigned, short, int, and then private. And then a new variable. Let me see if there's another one. Yeah, stochastic. So in my case, I had a stochastic variable. You just do more UML to model your code. That's it, which is a char or a character, and then private, and then apply, and then I'm done with my variables because that's all I have. Okay, it's not all of them. I have this, right? Private. I almost forgot. Remember, we have constants. This is going to be quite a handful. So let's. This is a lot of code. A lot to implement in the UML. So I'm gonna have default rows, and then remember the class scope that's it describes static. You don't come here and write static. You don't do that. You're going to say const, start writing from const or const expression, whatever keyword is supposed to use. So const unsigned short int, and then the value. Remember, it's a constant. You need to specify what value used. So like I say, this is quite a lot. And then it's public. We chose public, and then I choose class scope because what it's part of the class, it's a static variable. And then I do the same thing for my default columns. So underscore calls. The type is const unsigned short int or unsigned short. I just decided to put it in full there. You don't have to. And then the next one is UJ pixel, default pixel, which is a const expression. So new default pixel, const expr uj pixel, right? And then its value is basically this. I don't know if this is allowed, but you need to put a value. It's a constant. So I'll put it like that, right? You can put a comment if you want, but there's no time for comments. Yeah, that's pretty much it. And then apply. And then you put the next constants. So I have min size and max size. So which is an unsigned short, right? So min size, its type, it's const unsigned short int. Its value is 0. Then it's class scope, it's static. And then new, now this is max size. And I know it's going to be const unsigned short int. Its value is 10,000. I just chose 10,000. But make sure if you're using short, don't go above 64,000 when you're choosing a constant, the value to put it in. Because unsigned short means that it's between the range 0 to 64,000. So min pixel size, which is 0, and then max pixel size, which is 255. Okay. So min pixel size, and then the type, it's const unsigned short int, its value, it's 0, and then class scope, then apply. You don't have to click apply all the time. You can just go straight up to new and then create the next one. Then max pixel size, the maximum pixel size is 255. No, it's the value is there, and then the type, it's const unsigned short int, and then class scope, because these variables are static. And then that's it. These are all your variables that you have. So we are done with variables or attributes. Now we go to operations. Operations, you always start the order, right? It's always advisable to start with the constructors, the order. You don't have to start with the constructor, but it's advisable. So your constructor should be at the top. So image, and then done, because that's just a parameterless constructor. And then I have a copy constructor. So I go to the parameters section because this constructor is a parameter. And then I click new to add a new parameter. Now it's gonna lead me to this section. And then I give the parameter a name, meaning the variable name. So UJImage or obj right hand side, whatever you called it. Okay, then I have to check the CVP, but whatever you called it, you can call it whatever name. The main important thing that they want to see is the types. Did you pass the right types and things like that? You can your names might not correspond, right, with the way you've written it in code. Doesn't matter. So I know it's going to be a const UJImage reference. Default value, you could put a default value because remember, functions, you can put a default value to say that if the user didn't provide the parameter, then you can do that. This is actually, yeah, it's actually a good technique, but let me not, I totally forgot you can do that. There's a cool way to make your code look nice, but we're not gonna do that. So get rows, get columns, and get pixel, right? So I know them by head. So now I need to put my accessors. So get rows, that's the name of the method. And then the type, meaning the return type. The return type, it returns an unsigned short. Or if you're like me, just write it in full unsigned short int. And then visibility, it's public, right? Remember, all these are public. And then inheritance type, we just leave it as leave final because it's not polymorphic, it's not virtual, and it's also not abstract. So leave it as it is here. You could say class scope if the method is static, it's a static method. You can choose class scope, but it's not. So we're not going to choose all of those parts. So get calls, which returns an unsigned short int, right? And then done. And then we have a get pixel, which returns a UJ pixel, right? But it takes in two parameters. So I need to go to the parameters section and click new. So what's the first parameter's name? This will represent the row. And then its type is going to be unsigned short int. And then I click on new again because there's two parameters. The next one is call. And then the data type is unsigned short int. And then apply. And then there's the accessor. Then what mutator did I have? Okay, I had the mutator to set the pixel because we're not told to override the double indexing operator. So there, hence it was mandatory for me to have the set pixel method. So the name will be set pixel, and then its return type will be void, and then it's going to take 3 parameters. So this is quite a handful. So row unsigned short int, and then new column unsigned short int, and then new pixel, which is the pixel that you want to set it to. Remember, it's a setter, and then done. So we have the set pixel. So most of the time, UJImage was the one with, yeah, it is the one with a lot of methods. So start with doing the design for UJImage. And then we have operator overloading. Don't be confused by operator overloading, right? Remember what I said, starting from the keyword operator up until that symbol, basically that operator, that's the function name. This whole thing will be regarded as a function name. So I need to override the assignment operator. Remember, the assignment operator is always there. You have no choice. So under name, I'm going to say operator equals to, because that's the name of the operator, operator equals to. And then the return type will return a UJImage by reference. And then since it's an assignment, it needs to take in a UJImage. So it's going to take in obj right-hand side. And then its type is going to be const UJImage by reference. And then apply. And then done. So that's how you add that operator. And then you add the next operator, which is operator plus plus, which is the pre-increment. How do I know it's a pre-increment? Because post-increment, you need to pass in a type int there. Even though you're not going to use that int, you just pass it. That's how you distinguish between the two. So it must also return UJImage by reference. Okay, so operator plus plus, that's the name of my function. Because it's the keyword operator plus that symbol that you're overloading. That's the name of the function. So I'm overloading the plus plus operator. So the full function name will be operator plus plus. And then it returns a UJImage by reference. And then it takes in no parameters. Done. And then the next one, remember, I still have this Murena here. I'm gonna stop there once I'm done. Yeah, that'll be the last function that I put in my UML. So I have a load from txt file and the save to dat. So let me add them. So load from txt, which obviously returns a void. And then it takes in a file name, which is of type string. You can just type string, right? You don't have to type standard namespace : :. You could do that, but it's not necessary. And then save to that, and then void, and then we pass the file name, which is of type string, and then apply, and then draw method. So I need to put the draw method, void, no parameters, apply. And then I like to put like I said, I like to put things in a specific order. So the destructor will be last. I'll add the destructor at the end. So let me go to the top here and add. It doesn't matter in what order you actually put it. Don't be like me. Just write in whatever way you want to write it. So I must overload this operator. So I know it by head, so I'm gonna just start typing it. I won't go back and forth. So the name of the function is the operator less than less than. That's the name of the function. So this operator, it's meant to insert, right? So it's going to return an O-stream reference. Remember, you don't have to say standard : : You don't have to do that. So the parameters, right? When you click new, right? It starts showing the first parameter. So obviously the first parameter is of O-stream, right? So I usually call it O left-hand side. So I'm going to call it that. It's of type O-stream reference. And then the second parameter is obj right-hand side. which is so I'm in settings, so I don't need it to be mutated, so it's const UJImage reference. Then apply, and then done. Now we need to add the last thing, which is the destructor. So I need to add the tilde character, which is that squiggly symbol. This is a tilde because it's a destructor, right? So I need to add that thing, and then UJImage, and then done. Yeah, if you've made it templated, then it'll be, you specify the template class here and say new. In my case, it's not templated. I didn't do bonus, whatever. So I'm gonna leave it like this. So apply and then okay. I think it's full, it's complete. Yeah, it's complete. Yeah, there's nothing missing. Oh, ish. I totally forgot about this. Let's put those the helper methods, enforce range and what. But most of the time, I don't think your tutors will pick it up because look at how much this thing is. How will you pick up that, oh, this Morena forgot to put the helper method? They'll never pick it up because it's a lot. They don't have time to be going through every single detail. But I forgot to put it, so we need to put it. So enforce range void. So it enforces range. So it takes in 3 parameters. So it's gonna take in the value to enforce, which is of type unsigned short int, and then followed by the minimum. So I'm gonna say minimum or call it minimum. And then it's also of type unsigned short int, and then maximum, it's also of type unsigned short int, and then apply. Like I said, I like to put my destructor at the bottom, so I'm gonna select the function and then click the up arrow to move it up. So you see, now it's moved up. Just the preference. We don't have to structure it the way I'm doing it. And then I have all those 3 methods: constructor, copy constructor, and all of them they return void. So the constructor, it needs to be like the fully parameterized constructor, which is the one that is 3. In my case, it's not there, but it's fine. They just put it. So constructor, what parameters that it take in? Rows, right? Unsigned short int, and then columns calls unsigned short int, and then last one is pixel, which is of type UJ pixel. Then apply. Then I'm just gonna move it up, so up. And then the second one is copy constructor method. So copy constructor, which returns a void. And then let me think. It's a copy constructor, so it takes in a UJ image. So obj reference const UJ image by reference, because it mimics a copy constructor, so it must have the same parameters. And then the last one, which is the easy one, so destructor, just void it as no parameters. So apply, and then I'm gonna shift it up, so move it up, and then apply, and then okay. So it's quite a lot. You see, UJImage is quite a big class, right? Yeah, it can't even, yeah, okay, yeah, this is some, yeah, so this is UJImage. See, it's quite a lot. It's quite a handful. So I'm done with UJImage. So remember, when you're doing your UML, you're only going through the header files. Yeah, because you just want to see how your class is, only the header files. So that means I can close everything else. So I need continuous renderer, stochastic I have, UJImage I have. Okay, yeah. I just need the header files. So let's start with the base class, right? So the base class is called renderer. So I'm going to copy the name so that I don't struggle with spelling and things like that. So, I don't have to think too much about the spelling. So render attributes. And remember, before I continue, remember render is what? Abstract. So you need to choose this abstract keyword. So click here because it's an abstract base class. They told you in the PDF. So attributes, and then do I have it open here? Okay. So if you remember, if you don't believe me, It's an abstract base class, they told you. So that's they mean you must do the right thing in your UML. So I need two constructors, which is no args and parameterize. But let me start with my variable, which is position underscore position. So I'm gonna say new under attributes underscore position. That's the name of the variable. It's of type position, right? And then it's private. No, it's base class. So it's protected. Yeah, if I remember well, yeah, it's protected. And then so they want to see all this UML notation. You better do the right things. Then I have the default, no, parameterized constructor. Then I have the parameterized one, which takes in a position of type position, right? And then apply. And then, yeah, the other ones are easy to do. Then we have the default position. Remember, the default position is static. So keep that in mind. And it's a constant expression. Okay, it's an attribute, my bad. It's an attribute. So we go under attributes, default position. So which is a const expression, const expr of type position. And then it's public, it's class scope, meaning that it's static. And then the value, I have to go to my this and then copy the value. And then copy the value there, then apply. Remember, it's public, so that's why I left it as public. And then new, in terms of when it comes to my operation, I have this virtual method, which is the draw, right? So let me show you how to do this virtual method. Be very, pay attention here. So it's going to be called draw, and type is void, return type is void, and then the parameter, it's UJImage, right? Which is that UJImage by reference, right? But then this function, remember, okay, its visibility is true. This is for public, right? Which is true. But then when you look at things like this inheritance type, what type of a method is it? It's polymorphic. It's virtual. So click polymorphic or virtual, or you could say it's abstract. You could do that because remember, it's a pure virtual, meaning that it's abstract, meaning that it has no implementation. You could choose that, but just for safety purposes, they just choose polymorphic or virtual because that's pretty understandable, right? That's easy to remember. It's polymorphic virtual. And then once I've clicked there, I'm done. It should, if you check in your, it's a slight difference, right? You might not really see it. It's supposed to make it a bit slanted, like, yeah, like a bit cursive. It's supposed to do that, but it didn't. But yeah, it's a slight, you won't really see the difference, but yeah. Or you could also do this. You see, abstract, right? It doesn't really denote whether it's abstract or not. You could go to under stereotype and say less than, and say abstract, right? And then greater than, greater than. You could say that. I think it should show there. Yeah. You see abstract. Okay, I don't need. Okay, I don't need to put those. It does put it for me. So let me remove that and put apply. And then you see it's going to say abstract. But as long as you clicked abstract, it's fine. The stereotype, it's up to you. If you feel like your assistant might be blind enough not to see that this class is abstract. So renderer, yeah, you'd be shocked. I had a student that I was tutoring last year. She got wronged on a preg, I think preg 8, whatever. Because the assistant was like, where did you call the distract inside main.cpp? I was like, damn. That's a first. That's my first time hearing such. So the tutors don't really know anything. So sometimes you get lost, you lose marks for no reason. So, some tutors are really that blind. So put abstract keyword there. Under stereotype, just write abstract because they're just that blind. Imagine asking a student, where did you call the distract? Hey man, you're calling distractors inside, you're calling this distractors now. Very spiritual. So render, okay, so render the distractor. And remember the distractor is also virtual. So I need to click inheritance type and say click polymorphic virtual. And then apply. And then done. Yeah, that's it. And then I create other child classes, which is the stochastic and that other one. So I'm gonna go to stochastic first, and then copy, and then stochastic render, and then attributes. We need to check attributes. It just says the chance, which is an unsigned short. So underscore chance, unsigned short int, and it's private. Then apply. That's the only operation it has. And then we need constructors, default parameterless constructor. Then we have the parameterized one. Then I add the parameters. So position and the chance. So it takes two things, position and the chance. In that exact order, position and the chance. So I need to start by saying position of type position. And then next parameter is a chance. So chance unsigned short int, and then apply. And then okay, I've got this constant. So we have this constant default chance. So I'm gonna go back to attributes, which is public. So I'm gonna leave it as public because that it's public, it's a constant. And then remember it's class scope because it's static. And then const unsigned short int, and then its value, it's 90% chance. So 90, and then done. And then we go back to stochastic renderer. And then we need that void draw method. So draw, and then void, right? And then parameter, it's UJImage of type UJImage reference, right? And then visibility, it's public, which is fine. And then yeah, you can still choose virtual, it's fine. You can just choose virtual. Yeah, it's still a virtual method, but not really virtual. It's only virtual if we can make it leave it virtual if we plan for the child classes of this child class to also inherit it. You can do that, but you can leave it as final. Yeah, it's actually, yeah, let's leave it as final because that's the final implementation. Yeah, let's leave it because it was virtual in renderer, then we implemented it, then it became final. So I'm gonna leave it as final. But if it happened that you had multiple inheritance, then multiple, yeah, things called whatever multiple inheritance, or basically your base class has there's like a hierarchy of inheritance, right? You have a base class, and then you have a child class. Then the child class is also a base class of another child class. If that was the case, then within the child class, then you'd have to continue making it virtual. But in this case, we don't have such complexity. So, okay, it's okay. I need to copy that name again. Stochastic render. Anyway, I'm gonna type that whole thing. So you need to put the tilde operator or the tilde symbol, then put the name, and then done. Apply, and then we're done. Then we create the other one, which is the continuous renderer. So continuous renderer. Oh no, okay, we're done. Yeah, we're done. I was thinking about the inheritance. I was like, okay, yeah, oh, that's something you denote later. You use those symbols. And then I have underscore max intensity, right? And then which max intensity is 255. So let's create them. So underscore, okay, no, okay, it's fine. Let me just type it. Underscore max intensity, which is of type unsigned short int, right? And it's private. And then we have the other one, which is called the constant, which is called max intensity 2, but it's in all caps. Its type, it's unsigned short int, and its value is 255. And then it's public, and then class scope because it's static. And then operations, parameterless constructor, parameterized constructor, which takes in a position first. So position of type position. Then it also takes in a max intensity of type unsigned short int. and then apply, and then the helper method, the virtual method, the method that we override. So which is that draw method. So draw, it returns void, and then takes in an obj image, which is of type UJImage reference, and then apply. And then the last one is the destructor. So tilde followed by the class's name, apply. And then we are done with the full UML. So let's try to put it to, let's try to put the symbols, right? So, okay, this is fine. I'm gonna put it on this side. And then remember, these are the child classes, so they need to be there. So, and I'm gonna put this one up here, right? And then I'm gonna put this one here. And then I'm gonna do that. Okay, let me align it a bit. There we go. So let's start with the easy one, inheritance. So you're gonna choose the generalization or class inheritance symbol, which is that open diamond or the diamond that's not shaded in. And then I'm gonna click it again because I want to add again for the other class. Come on. So, okay, yeah, perfect. So there's the inheritance. So these two classes inherit from render. Then last but not least, we need to establish the relationship between these two. So you see, if it's neither this type of relationship that I'm going to list, it's neither inheritance, composition, aggregation. If it's neither those three, then it can only be what? Association. So association basically means that there's just, it's sort of, it's like, how do I put it? It's sort of like, it's technically, it has a relationship, right? It's technically has a relationship, but it's not really has a relationship. If you get what I'm saying? Why am I saying it's technically? Because if you look at the draw method here, don't we have a UJImage? Yes, we have. So it's technically a hazard, but it's like a hazard that's not really like established, well established. But before we do that, I'm almost forgetting that UJImage has a renderer. So this, I need to put the arrow this like this, and it comes from this one over here, right? We just says, so let me, I like things aligned, so let me do that. So we just says that this is a part of UJImage. Okay, let me, okay, and then now I need to fix this. And then this is a part of UJImage, but look at the type of relationship. It is a pointer. UJImage manages its life cycle. So I need to double click on this arrow. By default, it's aggregation, meaning it's a white diamond. Now I'm going to change it to composition because there's a life cycle dependence here. And then I'm going to click apply and then okay. You'll see that the diamond will become dark, right? Meaning that there's a life cycle dependence. So this renderer's life cycle is dependent on UJImage's existent. If UJImage does not exist, renderer, so does renderer. So render will stop existing. And if render does not exist, that means these two types of renderers won't also exist. So it's like there's a very solid relationship here. It's like sort of like a Romeo and Juliet thing. If you die, I die. You are my oxygen, you are my everything. Sort of like that. That's composition here. So we have established, okay, you can get your full marks here. They should give you full marks, but we still have UJImage defined within render. So what type of relationship does render have with UJImage? Because we have established that UJImage's relationship with renderer is that UJImage yeah, so UJImage, yeah, so let me see. So UJImage manages this life cycle of renderer, but renderer does what? So the association, it's all about the other class knows about the other class. So renderer knows about UJImage, right? So that would be association in this case because it's neither inheritance, neither composition, it's neither aggregation. So it's association, meaning that they just know about each other. It's like, oh, it's like, for example, we're acquaintances, right? I don't know you like that, but I just know you. For example, I see you in class, but don't get it twisted. Don't come to me and be like, hey, can you do this or that? I don't know you like that. We just know about each other. Or maybe it's this thing of like you and your friend, your friend talks about another person, but you've never met them. You just know about that person, right? So that's the type of relationship Render has with UJImage. So how do we denote that? It's what's that keyword? Association. So there's association. You see, two classes are associated with each other. So it depends in which direction are they associated. So in this case, the direction is, you should say from renderer, the arrow should point from renderer to UJImage because renderer knows about UJImage, right? I hope I'm not making a mistake. I hope that that's right because it's my first time. Um, and then put that arrow there. So there we go. And then I'm going to can't I double click here? Yeah. So direction, right? You can choose which direction should it go. I want it to go from B to A, right? So let me do that and click apply. So you see now the arrow points there. So why is it pointing there? Because render is the one that knows about UJImage. So what type of relationship? Let me see. Okay, name. So the name, that's where you put the type of relationship. So what type of relationship? The type of relationship is that renderer draws onto the UJImage. So I'm going to say draws or draw. You can just always it's always that virtual method, right? Virtual method's name. So you can say draw or draws and then apply. Renderer draws onto UJImage. So it's in that direction. It draws onto the UJImage. Or you can just say draw. Oh yeah, it has to be draws because if you check your slide, they said for example, they made a lecturer and a student example. So the student asks the lecturer a question. So the one who's asking the arrow is coming from that person. For example, the render is the one that's drawing, so the arrow is coming from the render, so it draws because the render is the one that draws onto the UJImage. And then there's no way, even if there's no way you can I'm betting my degree here. There's no way you cannot get full marks for this. Even if you're to be marked by Dr. Stung himself, there's no way you won't get full marks here because you showed all of the relationships and you put everything there. So this is the full UML, and it's not going to change because you always have composition or aggregation. You always have a virtual method. You always have this thing. So it's always going to be this like this. And then you're done. I'm gonna say save as. Okay, I'm gonna say save as. Let me say export because I want to export it. And then you'll see here at the bottom, right? It's very important at the bottom of your when you're exporting, you choose the file type. Then you're gonna select there, and then you choose PNG. Or you can choose scalable vector, but this one won't work. This you have to export it as a PNG. Scalable vector, it's like with the more you zoom in, you don't lose quality of the image, but it doesn't really matter at this point because you just want to pass. So I'm gonna choose PNG. Let me see if it's there at the top. It should be there at the top. Yeah, let's choose the one at the top, this one, Cairo PNG, right? So let's choose that one. And then I'm gonna close this. So Cairo PNG, right? That's the one I'm gonna choose. Don't choose this one. I don't know this anti-base. I don't know what. Don't choose that one. Choose Cairo. And then click save. I just I just saved that. Don't know where I saved. Hey, you see now, I was too focused on explaining. So Cairo, and then I'm gonna save it on desktop, and then I'm gonna call it which paper is this? Is it paper A or B? Paper B 2022, right? So UML paper B 2022 CSC 01B1. Then save, and then let me try to open the image before I close. Then I'm gonna go to my desktop, and then I'm gonna open. And then there's your UML. Done. And then you get your full marks. So that's how you do the UML. I'll upload the video and the on the I don't know why students keep getting asking me about code or whatever. Look at the description of the video. I don't know how many times I'm going to say this. At the bottom, you see where my channel name shows the image in the channel. Below that, you will see there's a link to download these things. So good luck with your semester test.